Hi, my name is Chin Shen. I am from program 6 UR6523008 under FTCAN. My matrix number 2013928857. I will present about this our first lab for NMK21303 electronic analog circuit 2. This is our lab. Okay, this is my lab report. Then this is our lab sheet. So the objective is to demonstrate an inverting operational amplifier circuit, to demonstrate a non-inverting operational amplifier circuit, and to investigate the operational amplifier voltage follower. So this is some introduction about amplifier, operation amplifier, OPM. Okay, so this is the introduction. Then the schematic symbol and the pin output, the out pin, 8 pin. Okay, then continue is about introduction of inverting and non-inverting amplifier. Okay, then some formula calculation. Then okay, here is start our lab. So the component that we need is resistor, IC, DC power supply, function gen, oscilloscope, and breadboard. But this one is our first lab, so we are doing online. Okay, so this is the procedure and the circuit. This all circuit we are using multi-sim online. Okay, so now I will try to present the first one. Okay, this one. This is a multi-sim online. Okay, so this is my circuit. Okay, this is my circuit. This one is inverting OPM. Okay, so inverting OPM, the power supply connect to resistor R1, then connect direct to a negative of amplifier. Okay, so this one is my circuit. Okay, so step one, we need to place our component for DC power, AC power supply, DC power supply, then resistor, and OPM 741. Okay, then connect it together. So this one is my circuit. So we set the resistor for R2 is RF 4.7K and my RI is 1 kilo ohm. Okay, so here I will start to run, but this one I cannot get result because I didn't probe the voltage probe. So now I put for V in and V out. So I will get the output result. Okay, for V in is negative 799 millivolt. Then for the V out is 3.75 volt. So I also can get the graph output waveform. So this is my output waveform. Okay, so my V in is here. So I can adjust it right here. Okay, so my V in, the maximum peak is 995.42 milliwatt. Okay, so I can set this by using cursor. Let's say I set cursor for x-axis, so means it's straight line. Then cursor 1 is the green color for output. Cursor 2 is blue color for voltage input. Okay, so I just adjust, then I can get the result from here, the bottom. So this one is my voltage output. Maximum voltage is 4.67. Then we need to record in the Microsoft Word. Okay, I already recorded. Then this is my report. So here for the first one, okay, 4.7K. So this is my output waveform. Then this is my circuit. And then this is the sum calculation part for gain AV. Then output voltage. Then this is the table for recorded. calculate value and experiment value. Okay, so continue for the second part. I maintain, then for RF will change to 10 kilo ohm. Then we get the output waveform will different. So let's say I change here. This one, double click, then I can adjust to 10 kilo ohm. Okay, then I will run. Okay, so my graph is different. Okay, so I just yeah, for the axis, just press it, then we can automatic get the new waveform. So my maximum peak value is 9.9 volt for voltage output. Then for voltage input is 995.42 millivolt. Okay, so this is my schematic. So for probing, I will get this result. Okay, then for the third one is 33K, 33 kilo ohm for RF. So same, here I will change it to 30K kilo ohm. Okay, then I will run. So this is my graph. Okay, if the resistance is too high, then it will make the amplifier will automatically generate. Then the output waveform will be a bit not so perfect because there are some noise. Okay, so if our resistance for RF is too high, then we will get the output waveform like this. So it is not fully curved waveform. Okay, so if the RF less smaller, then the waveform will be more perfect, more curved. Okay, so same. This one, the result that I get is V out 15 watt. Then for V in is 999 milliwatt. Okay, so for the part B, there's 4 questions we need to answer. For question 1, why the output waveform will be clipped? So the output waveform has been clipped is because of the exceeding the input common mode voltage range or the input differential voltage range of the amplifier. So why it called inverting amplifier? It called inverting amplifier because of the OPM change the phase angle of the output signal exactly 180 degrees out of phase with respect to input signal. Means this one for the output waveform, it is out of phase, so change 180 degrees. For the V out is from x-axis 0 up and down, but for the voltage input it will be opposite. We'll start from down, then slowly up and increase and decrease. So they are different. One is out of phase and one is in the phase. Okay, so my part B, this is my part B, non-inverting operational amplifier. So this is same calculation. Then my table. So this is my circuit and output waveform. So for the non-inverting operation amplifier, okay, there is okay, okay, so I will present my question first. Why is called non-inverting amplifier? Because of OPM is an operational amplifier circuit with an output voltage that is in phase with the input value, input voltage. It is complement is the inverting of OPM, which produce an output signal that 180 degrees out of phase. Okay, so same, we just change our schematic. This one circuit, but this one is inverting. So if I want to make a new one, so we need to delete all, then make change again. So from here, let's say this one. Okay, I need to so negative. Okay, so negative of input signal. Okay, then connect to the ground. Okay, then this one for R1, same, connect to the ground. Then for this positive pin, we will connect it direct from here, the system. Yes, correct. Okay, so now we can measure our V in and our V out. So if this one is 33K, just press run. Then the graph we get is like this. So we just move to the maximum. Okay. So the value that I get for 33 kilo ohm RF, I will get 15 watt and 996 milliwatt for input. So I have recorded in here. Okay. So for 32K. So my V out is 15 watt. Okay, then my V in is here 990 something. So if follow my previous lab, it's 990.43 milliwatt. Okay, so this is my report. So in the discussion during this inverting and non-inverting amplifier lab, we know that the non-inverting OPM is an operational amplifier circuit with an output voltage that is in phase with the input voltage. So the output voltage can then be given as V out equal V in plus V in over R1 times V R2. Okay. The gain is then V out over V in equal to 1 plus R2 over R1. So for the inverting amplifier, the inverting of OPM configuration is one of the simplest and the most common used OPM topologies. There are two very important rules to remember about inverting amplifier or any operational amplifier for the matter. First, no current flow into the input terminals. And the second rule is the differential input voltage is 0 as V1 equal to V2 equal to 0. So for the conclusion, okay, we can understood about inverting and non-inverting amplifier. So we can conclude that a non-inverting amplifier produces an output signal that is in phase with the input signal, whereas as an inverting amplifier, output is out of the phase. So this one is out of the phase. Okay. Both of the inverting and non-inverting OPM can be constructed from one OPM and two resistors in different configuration. Okay, so this is my lab report and this is my presentation about our lab. That's all. Thank you.